Okay, hi all. Today in this class we are going to discuss about Argand plane and the polar representation. So we know that z is equals to x plus iy. This type of numbers are called as what? Complex numbers, where x and y belongs to the real numbers. That we have seen in the last videos. Okay, so now I am trying to make you understand what is this Argand plane. This Argand plane is also called as complex plane. So next we will go for what? This polar representation. Okay, so I am going to write some examples now. So I will write 3 plus of what? 2i, or I will write 3 minus of 2i, or I can write minus 3 plus of what? 2i, or I can write minus 3 minus of 2i. Okay, for this every complex number I can represent them in ordered pair. So 3 comma 2 here, so 3 comma minus 2 here, so minus 3 comma 2 here, and next is minus 3 comma minus 2. Okay, this every complex number I have now represented in the form of ordered pairs. So that I am going to make a point on the xy plane. So this is I call it as what? X. This I call it as what? X dash, y dash. So this is nothing but the xy plane. If I represent these points or ordered pairs on xy plane, so here 1 2 3 1 2 3 1 2 3 minus 1 minus 2 minus 3 1 2 3 minus 1 minus 2 minus 3 1 2 3 minus 1 minus 2 minus 3. If I represent this point, so 3 comma where it lie in the first quadrant. This is what? 3 comma 2. So 3 comma minus 2 where it lie? 3 comma minus 2 will lie in the fourth quadrant. 3 comma minus 2 minus 3 comma 2 where it lie? So it lie in the third quadrant. Minus 3 comma 2. So minus 3 comma minus 2 where it lie? It lies in the what? Fourth quadrant. So here it is what? The point minus 3 comma minus 2. What I did here? First, before it was a complex number, I make it as a point, then I assigned it on the xy plane. Now this xy plane is called as what? Complex plane or Argand plane. Okay, if I assign a complex number as a point on the xy plane, that plane is called as complex plane or Argand plane. Okay, so if you see the numbers, you should be able to tell that in which quadrant it lie. For example, if I write 3 plus of what? 4i. So here the point is what? 3 comma what? 4, which lies in the first quadrant. First quadrant, the points will be plus comma plus. In the third quadrant, the numbers will be of the form minus comma minus. Here plus comma minus. Here you can write minus comma plus. Okay, that we have seen in what? Previous standards. Okay, so now this is called as Argand plane or the complex plane. So complex plane or the Argand plane is the plane which the complex numbers are assigned as a point. Okay, so now we'll go for the polar representation of the numbers. Okay, so it is very much easy concept. So as per your textbook from the first year, so exercise I think 5.2 is based on this only. Okay, so they will ask you to find the modulus. They will ask you to find the argument or amplitude. They will ask you to represent the numbers in the polar form. That we are going to see. Before that, I am going to see the numbers which are purely imaginary. Then afterwards we will go for the numbers purely real numbers. So before that, we will study about what is this polar representation. For example, z is equals to x plus iy is the number that we can write in the another form which is called as polar form, that is r cos theta plus of I sin theta, right? So that we are going to know this now. What is this theta? What is this sin theta? This also can be written as r common out, ir here, r common out. What is remaining? Cos theta plus of what? I sin theta. Okay, so as I said, now only this x comma iy can write as a ordered pair xy that I can represent on the xy plane. Here I am going to take a xy plane. This is x dash, this is y, this is y dash. So for example, the point lying here, for example, I will take this is the point x comma y. What it says? It says from यहाँ से यहाँ तक distance कितना होता है x, from यहाँ से यहाँ तक कितना distance कितना होता है y. So this point is represented like this. For example, if I want to know the point at this distance through this way, okay, so this way is called as nothing but r. Okay, that r is nothing but what? Modulus of z. So we have seen in the previous class, so modulus of z means what? Modulus of z is nothing but what? Square root of x square plus of y square. That is nothing but the distance between the origin to the point. So modulus r, this r is called as what? Distance from the origin to the respective point on the xy plane or respective point on the complex plane. Okay, so now I will come to know, or now we'll see that how this cos theta and sin theta will come. So if it is the line making an angle of theta, then I will take two angles. First I will consider sin theta. Okay, so what is this sin theta? Sin theta is nothing but what? Opposite by hypotenuse, that we can write y divided by r. Therefore y we can write here r into sin theta. And similarly I will take what? Cos theta. Cos theta is nothing but what? Adjacent by hypotenuse, that is nothing but x by r. So here it get multiplies, therefore x is equals to what? R cos theta. Then I will replace in the equation here. What I will do here, exactly we were not knowing before that. Okay, so this was the polar form we are not knowing. So what I do here, I will replace this x and y. So what I can write here, z is equals to, x is nothing but what? R cos theta. R cos theta plus of I outside. What is the value of y here? R sin theta. R sin theta. If I take r common out, what is remaining? R cos theta plus of I sin theta. So this is called as polar form of the complex number. So both are same. This is number the normal frame. This is called as what? Polar form. So if I take r and theta in the what? Ordered pair, this is called as polar coordinates anta karitare. Okay, this is called as polar coordinates. Okay, so this is about what? So which kind of the form is called as polar form? Polar form is nothing but r common out, cos theta plus I sin theta, or also you can tell that r cos theta plus of I r sin theta. Okay, now the questions will be asked like this. What they will ask? Find the modulus. Find the modulus means you have to find r. So that is called as what? Modulus. One more thing they will ask you to find the argument r, what? Amplitude. That is nothing but you have to find the theta. Theta is called as argument or amplitude or amplitude. Okay, next type of the questions will be asked like this. What they will ask? They will ask you to find the polar form of the given complex number. Means I have to find this r and theta, I have to substitute here. Definitely I am going to get a polar form. Okay, first we'll see how to write the polar form of the purely real numbers. Then afterwards we'll go for the what? Purely imaginary numbers. Then afterwards we'll go for the what? Other type of numbers. Okay, so this you have to remember. Polar form is nothing but z equals to r cos theta plus I r sin theta. Okay, suppose the numbers are given like this. Suppose the number z is equals to 1, suppose the number z equals to minus 1, suppose the number z equals to minus 2, suppose the number z is equals to 2. So these are the purely real numbers. So all the purely real numbers are also complex numbers, right? That we have seen in the previous videos. Now I want to write them in the what? Polar form. So we know that what is a polar form? Polar form is nothing but what? Z is equals to r cos theta plus of I sin theta, so under the brackets. So what I have to do every time I have to find this r, then I have to find this theta, then I have to substitute in the equation, then I will get the polar form. So suppose if I consider this is the what? Y-axis, this is what x-axis. For the sake of simplicity, consider it as the Argand plane or the complex plane. For example, this is 1, this is 2, this is what? 1, this is 2. So minus 1, minus 2, this is 1, this is 2. This side also numbers will be there. This is x, this is x dash, this is y, this is y dash. Exactly 1 where it lies? It lies on the x-axis. What is the distance? Distance is nothing but 1. Therefore, r value is how much? R is 1. r is nothing but what? Distance from the origin to the point. How much is the distance? Distance is 1 unit, therefore r is how much? 1. Now what is the line? This is the line which is lying on x-axis. What is the angle made by this line with the x-axis? 0. Therefore, so cos of 0 plus of I sine of 0. Finish. If the number is purely real, which always lie on x-axis. Okay, if it is minus 1, where it comes? It comes here. So what is the distance between origin to here? 1 unit. Therefore r value is how much? Again 1. What is the angle made? From yahan to yahan, yahan se yahan tak. Therefore how much is the angle with the x-axis, which makes an angle of 180 degree? That is nothing but you can write what? Cos pi I sine pi. Okay, similarly we can write z is equals to minus 2. So it is what? Minus 1. It is what? Minus 2. So this is 1 now, this is 2. Z is equals to minus 2 means where it lies? It lies on y-axis. Sorry, z is equals to minus 2, which lies on here what? X-axis only. Why? Because so here if you see only the real numbers which lie on the x-axis. Minus 2 means yahan. Therefore what is the distance from the origin? 2 units. Therefore r value is how much? 2. Then what is the angle theta? Angle theta is nothing but how much? 180 degree. Again you can write cos pi plus of I sine pi. Okay, so simple. So 2, where it lies? 2 here. Then what is the distance from the origin? 2. Therefore what is the angle with the x-axis? 0. Therefore we can write z is equals to 2 into cos of 0 plus of I sine what? 0. Finish. If the number is purely real, which lies on the x-axis, if the number is positive, then theta is 0. If the number is negative, then theta is pi. Okay, so according to the point it lies, we have to take the what? The numbers or the distances. I hope it is clear. So next we will see how to represent the purely imaginary numbers, to see how to represent them in the polar form. For example, if it is z is equals to I, z is equals to minus I, z equals to 2I, z equals to minus 2I. Okay, for example, these are the purely imaginary numbers. So how to write them in the polar form? To write them in the polar form, I want to find r and I want to find the theta. So that I am going to take use of this complex plane. Complex plane means if I am denoting the numbers on the xy plane, then this plane is called as what? Complex plane. Okay, so I means I, 2I minus 2I. Okay, so if they are purely imaginary, which lie on the y-axis, for example it is 1, if it is 2, if it is minus 1, if it is minus 2, then here also numbers will be there. I means 1I means which lie on the y-axis, that we can write 1I, where it lies? Here. Therefore what is the distance from the origin? Distance from the origin is 1 unit. Therefore what is the r value? R is equals to 1. Then theta I want. Theta is nothing but what? Angle between what? X-axis and the line. So how much is the angle? Angle is 90 degree. Therefore how much you are going to write? Pi by 2. That is nothing but cos of pi by 2 plus of I sine of what? Pi by 2. Okay, simple. For example, if it is minus I means which lie on the y-axis. So minus I means this side. So here it is what? Minus 1. So how much is the distance from the origin? Distance from the origin is how much? 1 unit. Again what is the r value? Therefore r value is equals to 1. Therefore I want to find the theta. Theta means from the x-axis how much angle it makes? It makes what? 270 degree. 270 degree means how much? That is nothing but cos of 3 pi by 2 plus of I sine of 3 pi by 2. Okay, simple. For example, z is equals to minus 2I. Minus 2 means plus 2. Where it lies? Plus 2, which lie on the what? Y-axis. So here, how much is the distance from the origin? 2 units. Therefore, r value is 2. Then how much is the angle again? Angle is again 90 degree. Therefore, cos of what? 90 degree means pi by 2 plus of I sine of pi by 2. Okay, simple. So again, minus 2. Minus 2 means which lies here. What is the distance from the origin? Origin to here is 2 units. Therefore, cos of what is the angle? Angle is again 3 pi by 2. Therefore, 3 pi by 2 plus of I sine pi by 2. Okay. So simple. How to write the purely imaginary numbers on the polar form. Okay, simple. So that I will take both at a time. Then I will explain the things once again. Then it will be totally clear for you. Okay. So we are going to see other type of the numbers also. So but before that we'll see the numbers here. For example, if it is z is equals to 1, z equals to minus 1. For example, z is equals to what? That is what? I, or z equals to what? Minus I. Okay, these four numbers I have to write so in the polar form. What is the polar form? Z equals to r cos theta plus of I sin theta. Okay, therefore, so here 1 2 1 2 1 2. So x dash, y dash. Purely real number, x axis. 1 means here what is distance? 1. What is the angle? 0 degree. Therefore what you will write here? Z equals to 1 into cos of 0 plus of I sin 0. Okay, this is the what? Value of this. Minus 1, where it is? Minus 1 is here, 1 is here. So what is the distance? Again 1. Therefore z is equals to 1 into cos of, what is the angle? If it is negative, pi by 2. So pi. So plus of I sin of what? I sin of pi. Why? Because angle is 90 degree. For example, if you take z is equals to 2, z is equals to 3, z equals to minus 2, z equals to minus 3. Simple. Z is equals to 2 into cos 0 plus of I sin 0. Z is equals to 3. 3 into cos 0 plus of I sin 0. For example, z is equals to minus 2. Z is equals to 2. Therefore, I cos pi plus of I sin pi. Z equals to minus 3. Therefore, 3 into what? Cos of pi plus of I sin what? Pi. That is I sin pi. I sin pi. Okay, simple it is. So if the numbers are purely real number, real number, real number, real number, real number, real number. Negative means angle is pi. Positive means angle is 0. That's it. If the numbers are purely imaginary, if I take, so for example, if I take z is equals to what? I and minus I. So if I take the z is equals to I, z is equals to I, how to write it? Polar form. I means where? Here it lies. 1, 2, it is minus 1, minus 2. I means here, what is the angle? 90. I 2i, 90 again. Therefore, z is equals to 2i. Z is equals to what? 3i. Z is equals to I. Point lies here. What is the angle? Pi by 2. Therefore, what is the distance? 1. Therefore, 1 into cos of pi by 2 plus of I sin of pi by 2. Therefore, z is equals to, so 2 means 2i here. So what is the distance? Distance is 2. Therefore what you will write? Cos of pi by 2 plus of I sin of pi by 2. So next is 3. Z is equals to how much? 3 into cos of pi by 2 plus of I sin of pi by 2. Okay, these are the positive real numbers, positive imaginary numbers. So similarly, if the negative z is equals to minus I, which is lies on the negative axis, minus 1 is here. Therefore z is equals to 1 again. Therefore cos value is how much? 3 pi by 2 plus of I sin of 3 pi by 2. Finish. So if it is z is equals to minus 2i, therefore z is equals to how much you'll write? So minus 2 means distance is again 0 to 2 is 2 only, 2 units. Therefore cos of 3 pi by 2 plus of I sin of what? 3 pi by 2. Okay, so this is about what? Explanation about the Argand plane, polar representation of the purely real numbers and purely imaginary numbers. Okay, if you want to understand, so to solve the next questions which are present in your exercise 5.2. Okay, so for example, number is of the form z is equals to what? I plus of root 3 plus of I, root 3 plus of I, or you can write 1 plus of root 3i. Okay, this kind of numbers will be asked how to represent them in the what? Polar form. Just follow me in the what next videos that you are going to get them all. Okay, so if you want me to explain any other topics also, you can recommend through the comment also. So if you want to contact and if you want to tell me the doubts, if you want to ask me the doubts, or if you are expecting some any other chapters, so you can contact me through 9611585556. This is my WhatsApp number, so you can contact. So for any other topics as well as for any so doubts you are having, for any good suggestion also, so that we'll accept your all suggestions. Okay, thank you.